is the multiplication, addition, subtraction. So next one is exponents. You ever heard about the exponents?
Exponent? Yeah.
Yes, exponents. So exponent is there. We know that.
Is the is it like the little like oh my god, why is it lagging so much?
It's lagging.
No, I was about to say something, but never mind.
Okay. So exponent is the okay. So we know that when we add 5 plus 5 7 times, we use multiplication.
Yeah.
6, 7. So instead of adding again, over again and again and again, we use multiplication 7 times. Now,
Yeah.
when we multiply 5 by 5 by 5 by 5 7 times,
Yeah.
1, 2, 3, 4, 5, 6, 7 times, we have another concept. We don't want to write like 5 times 5 times 5 times 5 7 times. It's somehow it's take time and very inconvenient. What is like a 5 times 5 100 times? Yeah, 5. So
Yeah. So it's just easier to like simplify it.
it's
Like simplify it into like multiplication.
multiplication, but yeah. So if it's 100 times, like 5 times 5 times 5, 100 times. Yeah, even easy to write it like 100 times. So we have another concept which is called exponents. We write it. This is called exponent. So we write it as if it's 5 times 5 7 times. We write it as 5 to the power 7. To the power
Yeah.
7. Have you ever seen this?
Yeah, I think I have.
Yeah. So this is called exponents. This is called exponents. And as you may know, in exponents, the number 5, that is multiplication of them over again and again. This is called base. This is called base. And now 5 multiplied 7 times. The 7 at the subscripts. The 7 at the subscript, call it power.
So it's like 5 to the power of 7.
Yeah. So in order to read it, it's 5 to the power 7. And the 5 is the base, 7 is the power. So 5 times 5 times 5 times 5, 7 times. Now we no longer just write it over and to write it over and over again. We write it as the exponent form. So
Yeah.
5 to the power 7. We call 5 is the base, 7 is the power. Okay. Next. Now, exponents again. What do we call example one, 5? Sometimes
This is still exponents, right?
yeah, this is exponent. So these whole things is called exponents.
Yeah.
Yeah, this whole thing is called exponent. While 5 is base, 7 is power. Other one is we have to address them. We have way to address them. Several ways to address them. For example, 5 to the power of 2. These can be called these can be called 5 to the power of 2. So this can be called either 5 to the power of 2,
Yeah.
5 to the power of 2, or this specifically because power, small power, we call it pi square. Pi square. Pi square. Because 5 times 5 is 5 square. Another one is okay. Another one
5 to the power. Sorry, what?
5 square. 5 to the power of 2.
Yeah.
It's 5 to the power of 2.
So base. So 5 to the power squared is the same thing as 5 squared. Like 5 to the power of 2.
Yes, 5 to the power of 2 and 5 square is the same. Power of 2.
What about like 5 to the power of 3?
Okay, now 5 to the power of 3. Yeah, now you can read it. This is 5 to the power of 3. Or in other words, okay, 5, this is 5 to the power of 3. Or we can call it 5 cubes.
So it's like there's like different words if like the power is like different.
No, the power is still 3. Power is still 3, but
No, no, no. Like 5 cubed or like 5 squared or.
5 square is power of 2. 5 cube is power of 3. How about 4 to the power of 4 and we have subscript 2. So you can either call it 4 to the power of 2 or 4 square. So
Oh, okay.
they have two names, right? You can either address it 4 square or 4 to the power of 2. Similarly, if you have 4 and subscripts 3, we can call 4 to the power of 3 or 4 cubes.
4 to the power of 3 or 4 cubes, right?
Yes, or 4 cubes.
Because the power is 3.
Yeah, because the power of 3. Now, another one is 5 to the power of 4. Okay,
Um, yeah.
that is already called. So, this is, what is this
Sorry.
called? Okay,
All right, never mind.
okay. So, when 5 to the subscript of 4, this is called 5 to the power of 4.
Five
Do
to
they
the
have
power
the nickname?
of.
Do they have the nickname? No. We only have the nickname for power 2 and power 3. From power
All right, yeah.
4, power 5, power 6, we don't have the nicknames. Nickname is 5 square, 5 cube. Why the 5 square, 5 cube is also we call because it's involving with the geometry. Geometry, you know the shape, there's shape called square. So in order to
Yeah.
find the area of that square, we need to multiply their side by their size.
Oh, because perimeter plus uh length multiplied by 2.
That is parameter, but the area
Oh, the area.
is side times side, right? Is times
Oh, yeah.
and the side the same, the size the same. So it's the side times that side again, which is size square. So we call it 5 square, 6 square. That's why the nickname exists. Cube is the same. We have a cube with 3 dimensions, something like cube. Have you ever played with the cube, like cube?
I have one. Yeah.
Yeah, yeah, so that is the cube. So in order to find the volume of the cube, we multiply a time b time the height, like base time height,
Yeah.
the width. So all the sides are the same. That's why it's a time a three times. So we call it a cubes. But beside that, there's
So
no any, yes,
so like 10 cubed or 10 squared or like
10
3
squared.
squared.
Yeah. So, but only for the power of two and power of three have their nicknames. Power of four, there's no dimension that it exists in geometry. So no nickname. But in order to address them, we call it 5 to the power of 4, something like that. Is it power of 100? Let's say power of 100, it will be 5 to a power hundreds. 5 to,
Yeah.
okay. So now evaluate. Now, how can we evaluate the exponents? I think this you will study in your next chapter, like chapter 3.
Yeah. Maybe.
So, right here. Example now, what is phi square? Okay, let's do it. This is called phi square. What is phi square?
5 squared is 5 times 5. Like
Yes,
5
correct.
to,
Phi
so it's
times
10.
phi is phi times
Uh,
phi.
oh, 25, 25, 25.
Phi, yes, 25. Correct. Now,
Yeah.
how about 5 cubes?
5 cubes is 5 times 5, which equals 25. And then it's 25 times 5, right?
Yes,
Which I
5
have to,
5, which is
uh, 125.
125, correct. 125. How about the um, 8 square?
8 squared.
Yes, 8 square.
8 squared, which is 8 times 8, which equals 64, right?
64, correct. What is this is called and this is equal to? This is number one. What is
Actually,
this
that
is,
is the one thing I struggle on.
yeah. What is this is called and this is equal to?
Oh, dude.
What is this called and this is equal to?
Is it like 121?
121. And what is this called?
11 to the power 11 to the power of 2 or 11 squared.
Correct. And how do you compute this? 11 times 11, right?
Yeah.
But 11 is, we have the magics to compute this. How did we do it?
How?
We write 11 to the side. Did you remember just yesterday?
It was like 1 and then it's like add the both and then it's like 121.
Yes, 121. This is the answer. Okay, so next another operation is uh, two. Okay, what is this called? What is this?
What is it's 2 to the power of 4 because it doesn't have like a nickname.
Yeah, so 2 to the power 4. So to what is this equal to?
Hold up. 2 times 2 equals 4 times 2 equals 8 times 16.
This is 2 times 2 is 4. Yeah, 16. Okay. I think I have one method for you to go through before we going further to evaluation. I have one thing for you to know and to make it fast. So 5, oh, we have 5 times 5. Now, 15 square or 15 times 15. What is the result? For
15 times 15.
yes,
Okay.
15 square or 15 square.
8, 9, 10, 11, 12. Is it 225?
225 is correct. So, in order to compute this, how did you compute it? 15 times 15, right?
Yeah.
Okay. Yes, and then like 15 times 15, we do multiplication 5 times 5 is 25. 5 here, 7, 5, and 1. So it's 5, 2, carry 7.
225. Yeah.
Correct. Now, how about let's see, 25 square? What is this equal to?
25 squared.
Yes, 25 square.
Let's see.
Okay. Twenty-five square.
Oh, wait.
Equal
No.
to
625?
625. 625. Now, I will tell you the hacks, the math hack that you just immediately put the answer. Yes, 25 squared is 625. That is correct. 35. So when the number ending with 5 and it's square, it's equal to. Now I think I can.
35 squared. Huh?
Now I think I can get the answer immediately. This 35 square will be 1225.
Did you already calculate that?
Yeah, you can double checks on that. But then I will tell you the trick. So you do double check first, and then we can and correct or not.
Uh, wha- oh, I almost. 10.
Almost
All right, 1,225.
20, 25. What is your result?
Let me check this again, actually.
Double check. 35 square equal to
10, 35 times 5, 15, 16, 17, 25, 8, 9, 10, 11, 12. Yeah, 1,200.
25. I,
Wait. I got different answers both times. The first time I got 1,125, and then the second time I got 1,225.
okay, let's do and checks together. 35 times 35 is the answer. Times 5 times 5,
25,
25. So 5 here, we have 2. 5 times 3 is 15.
15, and
17.
then 17.
3 times 5,
3 times 5 is 15.
15. So 1 here. 3 times 3
9,
plus 1 is
10.
10. Okay, so 5. This is 12, 2 and carry 1. So 1 plus 1 is 2 and 1. So the answer is
Ah,
1
okay.
through 25.
Okay, the second time was right.
Okay, okay. So here's the hacks, like the maths hack, if we call it something like that. But it only work for the number that end with 5. End with 5, like this
That can multiply with 5.
square. The square and end with 5. End with 5, end with 5. So
That are squared and end with 5.
yeah, and end with 5. So for example, 15, the result will always end with 25 because 5 square. It will end with 25. But these number, when it's 10, you have to multiply with the number consecutive increasing by 1. So 1 multiplied by 2 is 2.
Yeah.
Similarly here, 25 will be its end with 5, so the last digit is 25. And 2 multiplied by the increasing number of ones, which is 2 times 3 is,
Decreasing number 1.
yeah, like 2 multiplied by the number after that. 2 multiplied by 3. If this number is 2, you need to
Yeah.
take 2 multiplied by 3. 2 times 3 is 6.
6.
Yeah. Now for this case, it's end with 5. So it's 25 at the last digit. 3 times
Sorry. 3 times 4 is 12.
12. So this is the answer.
1225.
Right, faster. Now, maybe you don't believe, maybe this can be the coincidence. So let's try the other example to make it clear, like is it really work all the time or just coincidence?
Sorry.
35. So from what we, like the math hack that we just know is, what is the answer for 45 square?
45.
Yeah, 45 square.
The thing is, I didn't really get the map hack.
Oh, so the answer will be, we know that when it's end with 5, it's
Oh.
always result end with 25, right? Here, 5, 25, 5.
Wait, when it ends with 5, what?
When
Sorry.
we end with 5, like the number 15, 25, 35, 45, when it ends with 5, it's only work when it's ended with 5. 55. So the result of their square always end with 25.
It always ends with 25?
End with 25, yes. Always end with 25. For the
It,
number that is end with 5. Yeah, 25. And it should be like 25. Do you get it?
how does that happen?
This is like a math hacks. So here, the answer I can tell immediately, like, okay, this is 45, so it will end with 25. This is the answer. And
Oh, because it's
multiply,
5 times 5.
yeah, because 5 times 5, 25. And 4 we multiply by the number that is Bigger than that
That
one.
5
Yeah, 4 times 5, which is
is 20.
30. So this is the answer. See, you can give the answer just immediately.
Right.
45
Yeah.
square is 2025. Maybe you think, this is really happened or what? Okay, we can check. So 45 times 45 equal to 5 times 5,
5 times 5 is 25.
25.
What do you
5
and
times 4 is
20 plus
20
2 is 25. Is 2
22.
equals to 25.
So
And
five,
then we do it again. Well,
yeah, 4 times 5 is
20.
20. So 2. 4 times 4 is
4 times 4 is 16.
16 plus 2 is
18.
18.
Yeah.
So we have 5, 2. This is 10, so 0 and carry 1, 2. Right, so
So it's
the
2025.
correct. So our answer is correct. But we now maybe after we know this hack, we don't use this anymore. Like we still use, but sometimes I don't want to waste my time. So why did I need to do when we know the hacks already? Right? But do you get these hacks like math hack?
Yeah, because since you're like since it ends with 5, it's always gonna add up to 25 because
Yeah.
5 times 5 is 25.
Okay, now 55 square. You give the answer immediately. What is this?
So it's so it ends with 25. I know that for sure. And then 5 times 5 is it 2,225? Or did I get it wrong?
Okay, it's end with 25, but we need the other two digits. We need to
Oh wait, is it 27? Wait, no, no,
know 5.
no.
This is 5, right? So we multiply by the number that is bigger than 1. So 5 have to multiply by 6. Get it? 5
Hold up.
multiplied by 6, which is 5 multiplied by 6 is 5 multiplied by 6 is
Is it 3,025?
yes, you do it manually, right? You do it manually.
Yeah.
Okay, so I still want you to get these concepts. Make it fun. Okay, your answer is 30, 25. That is correct. So 55 square. But for me, I want like my student to give the answer immediately. So this, we know that when it end with 5 square, it's end with 25, the result, 25. Now,
Mm.
you just multiply the first number by the bigger number, by their bigger number.
By bigger number 1.
Yeah, by their bigger number by 1 is like, if it's 5 multiplied by 6, if this 4 multiplied by 4, this is 4 multiplied by 5. If that's 3 multiplied by 4, something like this. So for this case, 5 multiplied by 6 is 5,
30.
30. Yes, this is the result. You see, it's faster, right?
Yeah.
Yeah. So now, what is still the concept? 65 square. Can you give the answer immediately?
65 squared
Yeah.
at 25. Is it 42,000? Is it 42,025?
4225, yes.
Yeah.
Now you get the concepts. If you're not sure, you can check. Now, last one, maybe 85 square. What is this answer? You don't know.
Uh, 7225.
7225. Yes, this is the answer. So you can save a lot of time. Let's give the answer.
That is really cool. I
Yeah.
like
And this is not coincident. It's work every time. But only when it's end with five. When it's
it.
end with five.
Okay.
That's it.
Only when it ends at 5 and it's squared by 2.
Yeah, it's clever too. So beside the five, no, we don't have that.
Yeah.
So, okay, if you want to verify, you can double check here. Is it really happen or no? So, okay. So beside that, okay, this is just a little hacks. Beside that, the evaluation of these. Now, another example, like a real example, is the exponents. What 2 squared times 3 cubes equal to. So how can we compute this? It's look like 2 squared times 3 cubes
We multiply 2 squared first, which equals 4, and
equal
then 3 squared,
to
which equals 9 times 3, which equals 27.
27.
Because 3
Yes,
times 3 is nice.
correct, correct. Now you get the concept. So this mean this equal to
Yeah?
2 times 2, 2 times, and 3 times themselves 3 times. And then you just do
Yeah.
multiplications. 4, this is 9, this is 3, so this is 27. So 4 times 27
Is 7, 14, 21, 28.
is
128.
100.
108. 100, 7, 14,
This
21,
is
8, 2,
8 2.
8, 9. Yeah, 108.
108, yes. 100. Okay. Okay, so now you get the concepts of the exponents. This is not, okay, no, it's very hard, so give me one more example, and we will go 7 times 12 square times 11 square. What is this equal to?
7 times 12. Okay.
Square. So in the expanding case,
Times
that's right.
12
7
squared. 11 squared.
times 11 times 11.
12 times 2 is 24 multiplied by 22 equals to is it 322?
22. So your answer is 300.
Don't tell me it's wrong, but don't tell me it's wrong.
I don't know too. I need to do too. I need to do too because this is like a big number, but I think it should be like more than that because now this is already 121, right? 11 square is 121. 12
I
square,
multiplied it wrong.
yes. 12 square
Oh,
is 144
oh, bro.
and 7. So Once I 100 times 100, it should be like 6 digit number already. Times 7, it's maybe 6 or 7 digits number.
89.
Hmm. So maybe not.
Wait, so do I multiply the answers together or do I add them?
Multiply. This is multiplication, like dot dot.
What?
It's multiplications. So three numbers. Or you adding? Adding is 1, 200.
8, 2,
Six.
32, 33, 34, 36, 37, 38, 39,
12, 12, 11, 11.
64, 65, 66, 67, 68, 69, 70,
Three digits number times three digits number.
Why is this such a large number?
Yes. That should be like 6 digit number. Three digits, 6 digit number. The answer is
Hold on. 8, 9, 10. Is it 136,189?
136, 139,
89.
89. Okay, I'm not sure too, so let's check. So we multiply this with this. 144 times 121. It will be 441. Then 4 is 8, 8, 2, and
Oh no, I already see a difference, bro.
so 4.
Oh wait.
Is it already incorrect?
Oh wait. Actually, I multiplied 147, 141 multiplied by 7, right? And then I multiplied 121 by 7, and then I multiplied those answers together. Was I not supposed to do that?
So multiplication, we can commutative. So if you multiply these first and multiply these and the result, you
Oh,
multiply
it should
these first and
be
get
the
one result, and then multiply with this, the same.
same. Okay. We're good.
Or you can either multiply this and multiply with this.
Yeah.
That's the same. Okay, so now we have 4. This is 12. 2 we carry 1. 14, 4 carry 1s here. And 6, 7, and 1. 7 and 1. So it will be 1, 7, 4, 2, 4. This multiplied by 7. It will be 7.
No, there's already such a huge difference.
Yeah, it's already. Wait, this is. Okay. 7 times 4 is
Sometimes
82. 14, 16. 7 times 4, 20. 28 plus 1, 29. 7 times 7 is 49. 15 51s. 7 times 1 is 7, so 12. Almost right. So the answer is 12196 8.
Oh man.
Yeah, almost.
If I had that question on the test, I would not pass.
You need to make it slowly, correctly. Like one by one. If you do it very fast, it will be like,
Wait, multiplication is commutative, right?
yeah, it's commutative. You can either
Commu-
multiply
So
these.
which way do you think would be easier for me if I started like 147, 144 times 7, or like 121 times 7, or like multiplying 144 and 121?
You mean like you should do this first or this first, right?
Yeah.
For me, it's it's up to you actually. Like these should be the involving with the big number already, and then this will be multiplied with the big numbers too. So you can either do this first, the two beginning first, and then get the result to the second after. Because
Yeah.
the number is involving with 1 2 4, 1 2 4, so that there is not like big difference. But if you may see the number is like 5 times 25 times 11, for example, what should we do first?
Does it have to be a big number? A really big number? A
These,
lot.
what what should we do first?
9 to the power. Wait, what?
Because we know the trick that multiply by 11, so we should do this first, right? The results
Yeah.
immediately 275.
275.
Yeah, 25 times 11 is 275.
Hey, what? It
275.
didn't end in 25.
No, but we have another trick here. It's different trick.
Okay.
25 times 11, and this was yesterday. 25 times 11, how did we do?
Double check.
Oh, but don't confuse. We have a lot of tricks. We have a lot of hacks, but don't make it a mess. If you make it a mess in the exam, you want to make it fast, but then you can choose this method, but this method, then the result will be the
What is it? Yeah, this one. Was it properties of addition, subtraction,
property
or
in
division method?
multiplication, because multiplication.
Are you sure it's properties of multiplication? You
It's
have
not in
or
a property. It's not in a property. It's in the tricks that I just told you. It's not in the book. It's the
actually I don't think I have it because I don't see it.
uh,
It's one property, zero property, commutative, associative.
so you did say no. So the square of phi is one trick. So this is one trick. Wait, wait, this is